right, so here we are on the third page of the quiz, and I'll probably go ahead and do third page and fourth page in one video. Number 11 says, find the value of x in the figure below. Show work and circle your final answer. Okay, so we did some that were sort of like this. Let me just point out what's a little different here is that the 20.6 is the entire distance across the base. Okay, and the other ones we did, we were trying to find the area, so we needed to find the base and the height. Well, here you already have the base and height, but oh well, we're not trying to find the area, so it's not necessarily what we need. Similar though, in that we have two different triangles inside the big triangle. Okay, they're both right triangles. In order to find x, this angle, I need to know two side lengths over here. This 20.6 is not one of the side lengths for the smaller triangle on the right. It's the whole thing. So to be able to figure out what this part right here, just from here to here is, then I need to know what part, how much this is over here. So I could say 20.6 minus this part to give me this part. And then I could use these two sides to find the angle. So in other words, again, I'm going to start with the side where I know more, and that's over here. More is going on over in this triangle right now. So if I want to find this side down here, and I do, I think what I might do is redraw this. I've got 12.4, 58 degrees, and a missing side. So I have to figure out which function I need to use to find these sides. So here's my angle, 58 degrees. This is the hypotenuse. This is the adjacent. That makes this the opposite. So I'm using opposite and adjacent. That's the tangent. So tan 58 equals opposite over adjacent. I'm going to cross multiply to solve for x. So I get x times tan 58 equals 12.4 times 1. X is still not alone, so I have to keep going. It's multiplied times tan 58, so to get rid of tan 58, I have to divide it. Divide both sides by tan 58. And now x is alone, and that tells me what to put in my calculator. So 12.4 over tan 58 means divided by tan 58. I get 7.748. Let's call that 7.7. Okay, so this right here is 7.7. So now I can figure out what this green part is because the whole thing is 20.6. This part only is 7.7. So if I subtract 20.6 minus 7.7, well, it helps if the calculator's on. 20.6 minus 7.7, I get 12.9. So this part over here that's in green is 12.9. So now I'm going to work with that triangle on the right. I have two legs, and I need the missing angle. This is 12.4, this is 12.9, and I'm looking for this angle. So I'm going to have to figure out which sides I'm working with. This is the hypotenuse, so this is the adjacent. So adjacent here, hypotenuse here. That makes 12.4 the opposite. Okay, so I'm working with the opposite and the adjacent, so again I'm using tangent. So tan of angle x, this time I don't know the angle, equals opposite over adjacent. Remember, it's when you don't know the angle that you use the inverse. Basically, I'm using the inverse to pluck the tan off this side and move it to the other side. X equals inverse tan of 12.4 over 12.9. So in my calculator, I'm going to do inverse tan, second tan, 12.4 divided by 12.9. I get 43.86, which rounds to 43 degrees. So what this is saying is the tangent of 43 degrees, tangent of 44 degrees equals this number, whatever this is. Okay, that's what we're doing, is we're working backwards. It's like we have the answer for tangent and we're trying to figure out what angle gave us that answer. So x is 44 degrees. Number 12. An equilateral triangle has a side length of 6. We did this in class today, but it's an important problem, so let's do it again. If the side length is 6, this is what's going on. Find the area of the triangle. I just circled over here. Area of the triangle is 1/2 base times height. Okay, that's the formula for area of a triangle. This is the base. 6. It's the distance all the way across the bottom. So I've got the base. What I don't have is the height. So I'm going to find it. I'm going to call it h. And I'm going to notice that in an equilateral triangle, every angle is 60, which makes these little half angles up here 30. And what I have is I have a 30, 60, 90 triangle. On both sides, I have 2 of them. So pretty much my problem is like this. It's like I have just a random 30, 60, 90. And I know that the hypotenuse is 6 and the short leg is 3. Why is that 3? Because it's half of this whole thing. In a 30, 60, 90, short leg times square root of 3 gives you the long leg. So this would be 3 times square root of 3. If you don't like using 30, 60, 90 rules, you could use Pythagorean theorem. 3 squared plus x squared equals 6 squared. You'll end up subtracting, and you'll still get the same thing. You could also use cosine or sine or tangent. You could use a lot of different things to get this. This is approximately 5.2. So the height of my triangle is about 5.2. 5.2. And that's what I need to plug in here. Remember that when you go to get the base for the area formula, it's the whole base, because I want the area of the whole triangle, not just the green one. Okay, so area equals 1/2. The whole base is 6, and the height is 5.2. So when I multiply all of that, I get 15.6. All right, number 13. Really, this is only asking you to draw a picture. Sarah is gazing at the top of a cell phone tower near her house. So here's what I'm going to do. I have a strategy I've decided that might help you for these. So let's just follow my strategy. I'm going to draw the person or object that's doing the looking. Then I'm going to draw what they're looking at. Okay, she's really looking at the top of the tower. Okay, so then I'm going to do my line of sight. In other words, it's almost like her eyes have laser vision and we're looking at the laser out in midair. So this diagonal is always going to be your line of sight. The line of sight is always going to be sort of diagonal. Now the problem most people have here is, where do I put the angle of elevation or angle of depression? So here's what I'm going to suggest. Pretend that the line of sight, remember this is the line of sight, is the middle part of a letter Z. Okay? So draw a giant letter Z. It might end up having to be a backwards letter Z. But draw a giant letter Z that works with your line of sight as the middle part. Remember that when we talked about alternate interior angles, we talked about how they kind of make a Z. Well, these are the angles. Those are the angles we worry about in this situation. It really doesn't matter if she's standing at the top or standing at the bottom, because these two angles are alternate interior angles, so they'll be the same. So the angle of elevation, which would be right here, is the same as if it had said the angle of depression from the top, which would be right here. Okay, so again, you want to figure out what your line of sight it looks like. The diagonal line is the line of sight. Then make a giant letter Z. It might have to be a backwards one. And the corners, these little corners, are the angles that your angle of elevation or depression would be in. Okay, now I can complete my triangle. I would always draw the one that has the base on the ground. Here's my right angle. The tree, or excuse me, cell phone tower is 75 feet tall. And we want to know how far from her to the bottom of it. So that's this right here. So that is my picture. Incidentally, if you kept going with this one, you would use tangent, because this is the opposite and this is the adjacent. Okay. On the back, fortunately, these are both drawn for you already. Okay. This one says a kite with a string 150 feet long makes an angle of 45 with the ground. Assuming the string is straight, how high is the kite? Okay, so I just have to figure out the picture. The fact that it's a word problem is basically irrelevant now because they drew the picture for me. So I just have to figure out where these sides are, like are they opposite, are they hypotenuse, just like I would a regular problem. That's the hypotenuse. Here's the adjacent. So the one we want is the opposite. So I'm not working with the adjacent at all. I'm working with the hypotenuse and the opposite. That's sine. So sine of 45 equals opposite over hypotenuse. Okay. Cross multiply. And x is alone now, so it's time to pick up my calculator. And I get 150 times sine of 45. And I get 106.06, so 106.1. Okay. Notice that you could also have used 45, 45, 90s, because if this is 45, this is automatically 45. So the opposite and the adjacent here are actually the legs of an isosceles right triangle. They're going to be the same length. This is the hypotenuse. And so I would divide by square root of 2 to get that. So if you divide 150 by square root of 2, you should get the same thing. And we do. Number 15. Okay, remember please, I have a lot of people try to find this angle right here. Remember that what I said about the giant letter Z. Your line of sight, the plane looking at the air traffic control tower, makes a giant Z. Okay, so the angles I'm interested in are this angle and this angle. So if that angle is 32, that's the angle of depression up here. This one would be also. Doesn't even matter if we call it the angle of elevation or depression. They're the same. So once I know what that angle is, I can use it. And here's my right triangle. So here's the angle. The line of sight is always the hypotenuse. So this is the adjacent, and this is the opposite. So I'm going to use tan, opposite and adjacent. So tan 32 equals, the opposite is 12,000, the adjacent is x. Cross multiply x times tan 32 equals 12,000. Divide both sides by tan 32. And now it's time to go to my calculator because x is alone. So I'll get 12,000 divided by tan 32, 19,204. So x is 19,204. Okay, on the bonus. It may have been a bonus here, but I would strongly advise trying it and then watching me do it, or seeing what you can figure about it. Basically, if I have to find the area of all of this, then I really need a little bit more information than I have now. I need to know how tall this rectangular part is. I don't actually need to know the area formula for a trapezoid because I'm going to break it into a rectangle and a triangle. And the height of the triangle here is the same as the height of the rectangle. So what I'm going to do is I'm going to look at it just from the standpoint of that triangle first. and see if I can find that height. Now I could use, let's call it x. I could use, let's see, that would be, the hypotenuse is 14. This would be the opposite. So I could use the sine. I could say sine of 45 equals x over 14 and then solve. So if you want to do it that way, write down what I'm saying now. Sine of 45 equals x over 14 and then solve. But if it's a 45, 45, 90 triangle, remember that the hypotenuse is the leg times square root of 2. So if we're going backwards from hypotenuse to leg, we divide by square root of 2. So 14 divided by square root of 2 will give me x. Let's change that to a decimal. 9.89, 9.9. So the height of this rectangle and this triangle is 9.9. Now what about the rest of the triangle? Remember, it's a 45, 45, 90. Okay, if one angle here is 45, the other one has to be 45. So it has to be a right isosceles, so this also has to be 9.9. This part, if this is a rectangle, which it is, has to be the same as the opposite side also. So that's 22. So now I have everything I need. The rectangle has an area of base times height. So that would be 22 times 9.9. The triangle has an area of 1/2 base times height. The base of the triangle is 9.9. The height is 9.9. So 1/2 9.9 times 9.9. So in my calculator, I'm going to put those together. Excuse me. 22 times 9.9 gives me 217.8. 9.9 times 9.9 times 1/2 gives me 49.005. And when I add those together, I get 266.805. Let's just go with 0.8 to the nearest square unit. So really, excuse me, that's 267.